Good morning, Professor, and all the students who participate here. My name is Chhaysea, and I'm a student from Bangkok University. And today I'm going to discuss about the chapter 10, infinite sequence and the series, but I'm not explain the whole chapter. I'm just write the point 10.3 about integral test. So right now, see the content first. For the content today is for the first one is definition of the integral test, and second one is condition of the integral test, and the last one is practice. So now let's move to the first point is definition of the integral test. So the integral test is the test that we use to prove that neither the story is conversion or diversion. So it means that if we want to know whether our story is conversion or diversion, we can apply the integral test, but not mean all the story. We can use the integral test, and also there are another test that we can use. So but you will ask me that why we can use the integral to test the story, what relationship between them. So now let's see to prove this. First thing we need to assume that an f equal to the f of x, that f of x is positive for all the x that greater and or equal to 1, also decreasing and continue for the interval. So now let's see the graph here as is equal to f of x and the triangle. So now let's start with the triangle. So in order to find the area of the triangle, you already know that the area is equal to width times height. So the width here is 1, here also 1. So it means that all the height in here is all the same, but the difference is in the height. So if you want to find the height, and yes, also remember that here if the left endpoint, so in the left endpoint here, our height is equal to 1. So sub 1 and 2 here, if f of 1 equal to a1. So it means that the height here is a1, here is a2, and here is an. So in order to find the area of all the triangle is equal to a1 plus a2 plus dot here the an, and equal to the sum of from 1 to n of an. So you can think of another formula that we can use to calculate the area. As we study in the last chapter, that area under the curve is equal to integral from 1 to n plus 1 of fx dx, and is approach to the infinity. So as you can see in the graph here, the area that we calculate by the story is more bigger than the area under the curve, because there are some point that sticking out here. So we can say that the area of the area under the curve is smaller than the area of the outer triangle. And so now let's think of that. If the area is smaller, the integral, yes, the small thing is convergent or divergent. So it means that the bigger thing also follow to the smaller thing. So this point is mean that if the smaller thing is convergent, the big thing also convergent, and if the small thing is divergent, the big thing also divergent. So we can say that if the integral from 1 to n of fx dx is divergent, the story also divergent. So now let's see another case that we start we do with the right endpoint. So as you can see here, if we split to the right endpoint, the area of the triangle is smaller than the area under the curve, because as you can see here, there are some points, yes, that less than the curve. So in order to find the area of the triangle, and you will ask me that why here start with a2, and you can see here the height here is not a1, it's a2. Over here is a2, not a1. So we start with a2, but it's not affect any at all. It's not affect to the story is conversion or diversion. It just change in the sum. So if you want to get if you want to start from here, you need to add a1 to the series, and here that we can see the result. The sum of the area from 1 to n of an, and also the area under the curve is, if we plus here a1, we also need to plus here a1 here. So if we still add it, the area under the curve is still bigger than the area of the outer triangle. So if the bigger thing is convergent, the smaller thing also follow to the bigger thing. So if the integral from 1 to n and of f(x) dx is conversion, the series also conversion. And yes, remember that n is approach to the infinity. So the thing that you need to remember is that the integral test tell conversion or diversion, but that not necessarily tell the sum yet. Like I'm telling you in the last 2 minutes that the integral test just tell you that the series is conversion or diversion, and it's not tell the sum. Sometimes you can start with n equal to 1 equal to 2 if follow 3 is depend on you, but the series still conversion or diversion. It's not any get effect by the term that you start, and they just change in the sum. So conversion is not affected by add or sub infix of term to the series. And so the basic thing that you need to understand here, if the integral of f(x) dx is equal result in finite number, both integral and series are converged as n approach to infinity. And also, if the integral test is equal to infinity number, both integral and series are divergent as n approach to infinity. So I will continue to the next point that I'm talking about the condition to use the integral test. So let I'm say in like I say that it's not mean that all the series can use the integral test. So to know whether our series can apply integral test or not, we need to pass the series must pass through these three conditions. So the function f(x) equal to an must be passed through the three conditions. The first one is the function must be positive, have to be continuous, and also must be decreased. So I'm repeat it again. The function has to be positive, have to be continuous, and also be decreased. So in order to use the integral test, the thing that you need to know is that if the integral, if conversion, the series also conversion, and if the integral test integral is diversion, the series also conversion, and the condition to use the integral test is the function must be positive and have to be continuous, also must be decreased. So remember this thing that help you to do the integral test well. So let's move to the practice that I'm going to show you some example. So let's see the first example here. They want us to prove that whether the series is conversion or diversion. So before we do, let our f(x) is equal to 1 over x squared. So to know whether the function is passed through the three conditions or not, the first thing is that this function is always positive. Yes, it's true because x squared is always positive, so the function is positive. So it passed for the first condition. And another one is that 1 over x squared is continuous on the interval. So it means that there are no any point that make 1 over x squared is discontinuity, and also it's a decreasing function since the value of x become bigger and bigger. The whole value, the function value will approach to the 0. So it's a degree function. So it means that the function is passed through the three conditions. Now we can apply the integral test for the series. So in order to calculate the integral test from 1 to infinity, we need to know the formula that we already studied in the last chapter. Yes, the last few chapter. Yes, just I forget it already, but yeah. Here I'm also write for you here the integral from 1 to infinity of f(x) dx is equal to limit of integral from 1 to p of f(x) dx as p approach to the infinity. And yeah, we can use this to calculate the integral, and it final result is 1. So it's equal to finite number. So it means that the integral is conversion. So if the integral conversion, the series also conversion. So let's move to the example 2. Establish the conversion or diversion of the series using the integral test. Yeah, the exercise they tell us that we need to use the integral test in order to see whether our series is conversion or diversion. But we still need to prove that our function is passed through the three conditions. Yeah. So show it again. So for the first thing is that the function must be positive, continuous, and decrease. So For the first thing here, yes, I'm showing you the solution of to show that the function is decreasing by using the derivative. And yes, as you see the table here, from 1 to the infinity, our function is decreased function. So there, it means that our function is past the first condition already. So there are still another two condition. Fx is positive on the interval from 1 to infinity. Yes, in this interval there are no any value that make this function negative, and also on the interval from 1 to infinity there are no any point of the continuity for the function. So fx is definitely continuous. Yeah, it means that the function is also passed through the three condition, and now we can apply it to the integral test and calculate it as the same. The first one that I'm show you the formula of the integral. So, but in different is that for the theory it result in infinitive. So if the integral infinitive, it means that the integral is divergent. So by the integral test, if the integral is divergent, the theory also divergent. So now let's move to the last example. Here, establish the conversion or diversion of the series. And yes, and do the same as another example that I'm showing you. First thing we need to know whether the series is past the condition or not. So as you can see here, if fx equal to -2 over x times square root, but you know that x times square root is always positive on this interval, so the whole function will have the same sign as the -2, and it's negative, so it means that the whole function is negative. So we can use integral test to apply on this theory, but remember that even we can apply the integral test for this theory, we still have another test that we can use to prove it. And remember that even the function pass through the other two conditions, but we can still use it even because it's not passed through the first condition. So it means that among three, if your well function not pass one of them, we also can use the integral test. So like this theory, we can apply another test that is called P theory. Yes, and according to P theory, this theory is the conversion P theory. So yes, that's all for today. Thank you for your paying attention and hope you guys understand. And if any question, please comment down below. Thank you.